Good afternoon. My name is Brandon Carter. I'm an application engineer with Alloy PLM Solutions. I want to welcome you to the Alloy PLM Lunch Bytes series. I believe this is our 8th session of Lunch Bytes now. Today we are continuing with our ST3 series. Today's session will be on manipulating the steering wheel and maintaining design intent with live rules when using Solid Edge with Synchronous Technology 3. So we're going to take a look at some introduction to the steering wheel and live rules in ST3 in the synchronous environment. One of the questions we get is, how do I use the steering wheel? So the first half of today's presentation, we want to define the steering wheel, look at the tools to manipulate the steering wheel, and then the second half of the presentation today, we want to introduce live rules and how live rules help us maintain design intent and synchronous technology. We also want to take a look at advanced live rules and introduce those to you to see if any of you, or if you haven't, be aware of advanced live rules. So first of all, let's start off with a few definitions. This is a screenshot of the 3D steering wheel. And you're going to see we have our primary axis. This is a longer axis pointing straight up and down. And on the end of that's the primary knob. At the center is the origin. So the origin is really the base definition of the steering wheel. That's going to be our from location during moves, and that's going to be your base reference and also how the steering wheel is docked. So once again, the primary axis is a longer axis. At the end of it is the primary knob, and that would be how we would adjust maybe the vector orientation of the primary axis, and we'll take a look at that in a little bit. You also notice a secondary axis pointing straight out over in this direction. The secondary axis, and on the end of that we do have a secondary knob, and that helps us direct the orientation or the vector orientation of the secondary axis. You also see labeled number 3, there are cardinal points, and when we click on a cardinal point, that will adjust the primary axis in 90-degree increments. So if I click at the cardinal point on the left, the primary axis will adjust over to that location, so in 90-degree increments basically. The circular part of the steering wheel is called a torus, so if we want to rotate or invoke a rotate command of the select set, we will click on the torus. And then label number 8 there, kind of the blue tent, is called a tool plane. Whenever that steering wheel is lying on a face, and we're going to talk about how to manipulate that so it lies on the face just in a little bit. Whenever it's lying on the face, you can actually move your select set within that plane, kind of X and Y, so to speak, at the same time. So we're going to look at those tools. Also, as we go through today's session, I'm going to show you what control does to each of these tools and what shift does to each of these tools as well. The previous slide was the 3D steering wheel. Here is the 2D steering wheel. So if we select a whole, a face set as a whole, or maybe even a cylindrical face, a circular cutout, you will notice that this 2D steering wheel comes up, and you see some of the same labels as far as the secondary axis with the secondary knob to change the vector orientation. You have the primary axis and the primary knob. The origin, once again, the origin and the location of our steering wheel and our from point for our moves, and then once again the tool plane. So we'll take a look at both of these as we go. So if I click and hold the left mouse button, first of all, if you remember from our ST3 interface Lunch Bytes, whenever we select a face, you notice the steering wheel comes up. So when we select that face highlighted in green, you will see the steering wheel come up. When we hold our left mouse button down on the origin, that's how we move and dock the steering wheel. You see we're dragging it over to the side. So left click and hold the mouse button down will drag the steering wheel around. If we click on the primary axis, it's going to move that select set in the vector direction of the primary axis. So like I said earlier, it's very important. The origin of the steering wheel is your from reference. So you see that face will be moving from your from. And in this screenshot, you'll see that once we've started and we've clicked on the primary axis, we will specify a distance above that to a certain value. We could also select key points to that as well. You also notice that we can click on the secondary axis. You see in this screenshot, we have this kind of angled face selected as our select set, and I've docked the steering wheel out to the side. And one thing, as we're going through this, I'm going to try to show you a little bit of an example of this inside of Solid Edge. But keep in mind, you can always dock your steering wheel where it's most intuitive for you to make that change. So you see I've pulled the steering wheel off of that green selected face, and I've actually docked it to a horizontal edge behind there. And when we select that little secondary axis, that will do a linear move in that direction as well. Once again, the origin of the steering wheel is your from reference. In this case, we're going to key in a value for our 2 reference out in space here. Here we've pulled the steering wheel down so it's docked on the edge of the select set, and notice how the torus of the steering wheel is normal to that face. When we click the torus, it's going to start a rotate command, and you'll see that we now have an angular extent to define that. I mentioned the tool plane. Here's a screenshot of the 2D steering wheel where I've selected a hole. You see the secondary and primary axes there. We can move those kind of linear in that direction, but if I click inside the tool plane, you see I have more of a free-form move. I can kind of move X and Y at the same time. I can specify a value. In this case, I have 10 typed in, but I can also click on a key point. I'll show you an example of that just in a little bit. We mentioned just a little bit ago that when I click on a cardinal point, it will change my primary axis of my orientation there. So notice on the left, before I click on the cardinal point, the primary axis is pointing straight up. When I click on the cardinal point to the right where the cursor is, you see that now the primary axis is pointing off to the right. So the cardinal point is an easy, quick way to allow you to rotate the primary axis in 90-degree increments. So everything we just mentioned as far as clicking on the primary secondary axis, if we hold down Control, it will invoke a copy option. So you see we hold down Control, left click on the primary axis. Instead of just moving that face, it's now moving with a copy option. So Control with left click will copy and move in the primary axis. If I Control and left click on the secondary axis, as we saw before, we're quickly replicating a copy of that select set. And then here with the 2D steering wheel or 3D steering wheel inside the tool plane, if I hold down Control, it'll rip off a copy there. So it's doing the same movement types. Control just invokes the copy option. If you've been using synchronous or you've seen some synchronous tools, those are probably the most common things that you've seen in demos or what you've used inside your office. But what about some of these? And some of these are not as well known, so I kind of want you to think of these as tips and tricks too as we go through these. If I shift and left click on a primary axis, it's going to offset that primary axis. So you see on the left, before we did a move, but with the shift button held down, you see how it's offsetting the origin in the primary axis. In this case, I've offset it 4 millimeters above. And I'm going to show you an example just in a little bit. Maybe we want to move a face to a certain point that is 4 millimeters difference from a reference, then that's going to allow us to do that. I also can hold down Shift and left click on a secondary axis, and that will offset the secondary axis the same way we saw on the previous slide. If I shift and left click on the torus, it's going to actually rotate the steering wheel about the torus. So maybe, on the left screenshot, you see the primary axis is straight up, so let's call that 90 degrees. And maybe I don't want it straight to the left at 0, I want it more at a 45-degree vector. So if I shift and left click on the torus, you're going to see that that gives me a dialog box to type in something like 45 and lock in that other vector angle. So that's very nice when moving holes at a certain vector, as in this case. Okay, what about other ways to manipulate the primary axis? So what we're doing is manipulating the steering wheel to get our vector direction. So if I left click on the primary knob, which sits at the end of the primary axis, you're going to notice it starts free-forming, moving around. Notice how there's not a dialog box for me to enter, say, 45 degrees. Where this tool is used is if I have a key point in my part, and I want to say I want to move the end of this vector to line up with this key point. So that's why we do not have a dialog box for a value in this case. If I do want a value and not necessarily a key point, you notice that I can hold down Control and left click on the primary knob, and you'll see how the primary axis rotates normal to the secondary axis. So in the screenshot on the right, it's actually leaning straight back, so to speak, and it's kind of normal to the direction of the secondary axis. If I hold down Shift and left click on the primary knob, just as we saw before by holding down Shift and left clicking on the torus, you'll see that we can get once again that dialog box, say 45 degrees in this case, and get a different vector for the primary axis. Same thing basically with the secondary knob at the end of the secondary axis. If I left click on the secondary knob, you're going to notice I do not get a dialog box on the right to specify 45 degrees or whatever the measurement may be. It's more used for me to go out and select a key point to align that vector to. If I shift and left click on the secondary knob, you're going to see that I get the orientation. It rotates about the torus, just as we saw before. And if I hold down Control and left click on the secondary knob, it's going to rotate it back normal to the primary axis. So those are very similar. Just keep in mind, Control, Shift, with the knobs, the secondary and the primary knobs can allow you to get different vector orientations. And these last two here are really tips and tricks, I think. I use these a lot. You see on the left how the torus of the steering wheel is standing up, so to speak. If I shift and left click on the tool plane, which is inside the torus, notice how it switches the secondary and primary axes, and it basically will lie down the torus for you. So if I want to do a copy and paste operation with that torus lying down, that's a nice way to just lay down the steering wheel, so to speak. And finally, a real nice kind of tip and trick, if I shift and left click on the origin, it's going to maintain the orientation that I have the steering wheel. So as you pull the steering wheel around, it wants to snap to different pieces of geometry depending on which way you're pulling it and what type of face and whether it's at an edge and so forth. If I've set up the orientation of my steering wheel and I hold down shift and left click on the origin, I can let go of shift, it's going to move around and I can grab any key point and it's going to maintain that orientation. So first of all, if I just select the face, the steering wheel comes up. And right now you see how this face is lower than the one behind it. If I have that and I just hold down my left mouse button on the origin, you see how the steering wheel, you see the 3D steering wheel pop up. This is the primary axis, secondary axis here in the front, the torus, and you see the primary knob and secondary knob at the end, and then the cardinal point. So if I click this cardinal point closest to us, notice how it changes the primary axis towards that cardinal point. So that's an easy way to change the location of that. If I pull this steering wheel around, notice how whenever I get close to an edge, notice how it snaps. In this case, it snaps the secondary axis to the edge. I want to snap over here. Notice how, depending on what geometry I'm just pulling it to, it's orienting the steering wheel to me. And right now, that torus is normal to that face. As far as the movements go, right there's my primary axis. If I click my primary axis, obviously that's going to do a move. So the origin of the steering wheel is the front point. I can type in 3 millimeters. I can come up and say, you know, make this go to this point here. So that's defining my 2. If I want to rotate this face, I can snap it over. Notice how the torus is normal to my select set. So just by clicking on the torus of the steering wheel, I can rotate that face. As far as the knobs go, you'll notice whenever I just left click on the primary knob, notice how it kind of freeform moves around. I don't see a dialog box to specify an angle. And like I said, this would be a case where I want to come down and specify maybe a vector. Notice how I'm using the key point. Notice how I can snap to a key point to define that vector angle. So that's why we don't necessarily see that. You will also see that when selecting the secondary knob. But if I want to specify something like we saw on the slide with 45 degrees, if I hold down Control and left click on the primary knob, you're going to see that it's going to rotate and give me a dialog box. Maybe I want that 45 degrees. It's rotating normal to the secondary axis. I type in 45 and click, and now my vector is off in 45 degrees in that direction. If I do Shift, notice how it's going to rotate along with the torus. So this is very handy. Once again, I want to type in 45, left click to define. Now you see that instead of it being straight up and down, I've now rotated my primary axis 45 degrees in that direction. By holding Control on all those, that makes a copy. Just to show you one quick example here, if I hold down Control and left click on the primary axis, whatever move, if I hold down Control, that's going to create a copy. So you see I've just clicked, I've just created a copy of that one piece of select set, which is just that face. So that's why I don't have anything else there. If I click on this face, this front face, and I want to lie the steering wheel down, if I hold down Shift and left click inside the torus, which is the tool plane, notice how it just lies that steering wheel or that torus right down on the face. So if I want to do a copy and paste operation, that's a nice tip and trick. It kind of switches the primary and the secondary axes. If that's the orientation I want, notice as I just hold my left mouse button down and drag it around, notice how it flips orientation like we saw earlier. But if I come back here and I do the Shift left click inside the tool plane again, now it's lying down. If I hold down Shift and left click on the origin, I've let go of my Shift key and my left mouse button. Notice how wherever I move it around, it's going to maintain that orientation. So I can come up and dock it on that corner point, and it won't try to snap to the edge. That's a nice tip and trick that I use quite often. You see the 2D steering wheel, when I select this hole, I can move it, you know, X and Y, so to speak, with the cardinal points, primary axis, like you would expect. The other thing, if I click inside the tool plane, notice how I can kind of move that along the face all in one movement. So it knows it's tied to the face. I'm moving it. It's kind of like move face within plane. I can come up here and say, put that on a center point. If I click this particular hole or cylindrical face, I can click inside the tool plane and quickly come up and say align those. So I'm using that within plane inside the tool plane option. And what we're going to look at here is we're going to introduce the live rules for you and explain what kind of geometric relationships we're doing. So live rules are going to maintain design intent by looking for certain geometric conditions. So if we modeled a part to be symmetry, we modeled faces to be coplanar, concentric, live rules are going to help find those identities for us and help move those and bring those along for the ride. So the different live rules, and I'm going to show you this part here just in a second. We have, first of all, concentric. You see in parentheses, that is the keyboard shortcut. So as we're dynamically moving, we can quickly toggle that on and off. It's going to locate cylindrical faces just like you'd expect, whether it's a cylindrical face to an arc or a hole to hole or whatever the case may be. Below that's coplanar, so if faces lie in the same plane, so they're flush. Notice on the bottom left, if we click that top face, the three faces in red are going to come along for the ride. And I should point out that for this particular slide, the faces are highlighted in red. That's not what you're going to see inside a Solid Edge. The reason why they're red is for screenshot purposes to kind of illustrate that. So you see the select set is in green, just like it will be inside the program. And in the program, the faces will be blue, come along for the ride, but for this slide, for illustration purposes, they are red. Tangent edges. So you see on the left we have the original face with the tangent edges live rule on. You see you bring that up. Notice how the radius maintains and that tangency condition maintains. If with it off, notice how it does not. So pretty straightforward there. Tangent touching. Haven't used this one too much. This is one of the main things I have seen it used for. We have a construction surface in front. And notice with tangent touching, if we move that construction surface on the left, the steering wheel, then those arcs or rounds at the end, or whatever you want to call them, are going to be touching, so therefore tangent touching. Also up in the upper right-hand corner, you'll see that if you drive that cylindrical face on the end, it will drive the construction surface as well. Parallel, this is off by default. I'll show you the default live rules just here in a minute. But the parallel is used mainly for rotating faces. So if, for example, the front face, I dock my steering wheel down there and start to rotate, I turn on parallel. Every face, just like it sounds, the parallel to that will rotate as well. So it's a nice, easy way to be able to rotate multiple faces. Very, very similar with perpendicular, used mainly for rotating faces. You see on the left, red faces are detected, and the select set is in green. With that off, it's going to skew and not keep that normal. But with perpendicular live rule on, it will maintain that condition. So instead of us maybe window selecting all those face sets, we can let the perpendicular live rule help us out and bring that along for the ride for us. Symmetry. You'll notice down there I have a screenshot, and in between there we have a main symmetry live rule, and then you can turn on and off symmetry in each direction. So the symmetry we're talking about is about the base reference plane. So you see, maybe the YZ, XZ, YX reference plane, we can turn those on and off, and just like it sounds, symmetry. So if I move the face on the left in the green select set, it's symmetric about the ZY plane, so therefore the face across from it is going to move as well. In ST2, there was a coplanar axis live rule added. So if somebody modeled holes, we picked this face and we click 1, 2, 3, and we drew them in a line, well, that's design intent, right? We drew those to maintain alignment. Why not have a live rule to help bring that along? So you see that by selecting one of the holes, and it's very similar to the symmetric live rule in the fact that we have a global coplanar live rule here you can turn on and off, and then we have it in each direction. So if these are lined up in the Z direction and I move them left and right, they're going to all maintain a direction. You see the hole that we actually have selected on the slide is actually, they have them lined up in the Z direction and also the X direction. So as we move those dynamically, you'll see that both of them are going to maintain the alignment. So coplanar axis, that's what that live rule is basically for whole alignment. Same radius, it's going to control such that radius values are maintained when the model is modified. So in this example, you see we're just kind of free form moving the hole on the end with the green select set. And notice with this live rule how the adjacent arcs with the radius of 187 maintain as we move it around. Orthogonal to base, this is an interesting one. It's going to keep it normal to the base reference planes. So in the screenshot you see as we're pulling that hole highlighted in green, forward and backward, with the orthogonal to base live rule, notice how those front coplanar faces will tilt, and with the live rule on over on the right, you notice how they stay normal to the base. So my kind of tip and trick for orthogonal to base, if you're trying to rotate a face and it won't rotate, check and see if that live rule is on, because it may be wanting to hold that face and adjacent face is normal to the base reference plane. New with ST3, we have a lock to base reference plane, and one of the easiest examples to see where this comes into play is on the bottom left. You see where if we drew a rectangle and we started our sketch on our construction geometry on the XZ plane, and we extrude straight back away with a finite extent away from that, and then we come back and we have a solid now and we want to move that front face, you're going to notice that it is locked to the base reference plane. So what it's saying is that the face we're trying to move is locked to that XZ reference plane. If you want to move that face, all you need to do is turn off that live rule. We also have an option, instead of going through and turning off all the live rules, there's a quick option to suspend, and the shortcut for that is the U. You see the suspend up there. Maybe we want to turn off several live rules, maybe we're rotating different faces, and the case we have in the bottom left is these faces are coplanar, but as we start to rotate them, depending on which two faces, we may want to give it a little more degree of freedom, so to speak, and allow it to not use live rules and us pick what live rule or what conditions we want to rotate, what face sets I'm trying to say we need to rotate. There's also a restore, so if we have turned on and off a bunch of live rules and we kind of want to get back to the default setting, you see a screenshot down there with the defaults, what Solid Edge says the defaults are: concentric, tangent, coplanar, all the symmetries here, all the coplanar axes here. There's the same radius, orthogonal to base, lock to base reference plane. And one thing I should mention here, this is also to be able to include sketches with your live rules. This option here is to be able to include, and it's the bottom three. I think my cursor is coming across. I see it on another computer here, but this would be allow the reference planes to come through and also coordinate systems. But when we hit restore, it's going to go back to this setting. Also, whenever you close out a Solid Edge and end the session and open it back, that will also restore your live rules inside of Solid Edge. One tool that I really love is this pause. So as we're moving a set of faces and live rules are bringing other faces along for the ride and we see it dynamically, we can hit a V on the keyboard or click pause down in live rules, and it will pause it and keep the faces highlighted, so we can even rotate the model around. Maybe we want to turn on the background assembly, and it'll kind of keep that condition and allow that. And also you see if we have a lot of 3D driving dimensions that you have on the left, when you pause it, only the dimensions that are affected with that select set and those live rules will display during the pause. So it really allows you to interrogate and see what live rules is bringing along for the ride. And there's some color schemes to understand. So if a live rule is white, that means it's off. So you see parallel, tangent touching, and perpendicular are off down here. If it's red, it means that the live rule is found but it's turned off. So that means we've turned off concentric, but as we move that hole, Solid Edge is saying, you have that off, but I see that there's a concentric condition. If it's green, that means that the live rule is on, so symmetry is on, plus it's found. So it found a symmetric condition. If the live rule is yellow, that means it's on, and if we're inside of a move, that means that in this case tangency or coplanar is not found. So if it's green, it means that it's found and on. If it's red, it means the live rule is off and it is found, that condition. Also, I want to point out advanced live rules. I talked about the pause, but advanced live rules will pop up a window here, and it actually allows you to see true form of what live rule is moving what face and how many layers deep or how many levels deep these live rules are interacting with each other, and I'll show you that just in a second. So let's go ahead and take a look at a couple of these ideas. I'm going to run over a little bit. I apologize. Get talking too much sometimes. But here, if once again, just like we saw before, I'm going to unsuspend my live rules where I had them suspended earlier. But if I just move that face by clicking that primary axis like we saw earlier, notice how the other three faces are coming along for the ride. So if I hit V on my keyboard to pause, Notice how it pauses it. It shows the original location of that select set. It's showing what faces. If you look down in live rules, you see that coplanar is green. So that means that obviously it's on, and it's showing that it has found coplanar. And it's also found that symmetry. So as I move this face, the faces across from it are moving as well. So if I unpause that, and just to turn off coplanar, I can go down there and click it, or just a quick P on the keyboard. Notice how I've turned off coplanar. Now I have symmetry acting. If I hit S on the keyboard, notice how I've turned off symmetry and coplanar. Notice how they are now red down there, showing that they are off, but Solid Edge is finding that condition. So as we're moving that up and down, you see those are now off. If I hit S again, notice how it turns it back on. Hit P again, it turns it back on, and I get that coplanar condition. If I drag my steering wheel down and dock to the edge, we talked about rotating faces earlier. I clicked on the torus there. Notice how I'm picking up symmetry across from it as well. In the front here is a very interesting condition. We kind of saw some of it on the slide. But if I select that hole, and these are concentric, if I select the secondary axis, I want to pull this straight out in front. I've clicked the secondary axis. I'm pulling that forward. Notice the conditions we get. So I'm going to go ahead and pause this one as well. Notice how we got concentric. So the hole to the arc is concentric. The hole across to the other hole is concentric. The arcs are concentric to each other. We have tangent conditions with these vertical faces and these arcs. And then we also have coplanar across there, and we also have symmetry, right? That's symmetric, once again, about the ZY axis. So if I unpause this and I turn off, let's just turn off concentric, I hit C on my keyboard, notice how now it's just moving those holes. And the reason why both of them are moving is because they're symmetric. If I hit S on my keyboard, notice how I'm just moving one hole. So if I hit S again to turn it on, turn back on symmetry, I hit C to turn back on concentric, we're back to that case. Also, I mentioned the orthogonal to base. This is O, a shortcut there. And notice how, from the slide, notice I have orthogonal to base off. Notice how it's kind of tilting and not keeping those adjacent faces normal to the base reference plane. So if I hit O on the keyboard to turn that back on, notice how those vertical faces are maintaining its normal position to the base reference plane. So that's what we're looking at there. Just quickly to show you an example of parallel and how parallel and perpendicular would be, I'm going to turn on the parallel live rule. It's off right now, and L is the shortcut for that. If I'm going to drag my cursor down and dock it to the edge, and once again my torus is normal to that face, so I'm in a great position to start to rotate. And notice how whenever I rotate that, it's picking up all the parallel faces and bringing them along for the ride. So it's very nice. I don't have to go out and grab those faces. I don't have to make each of those edits separately. It's grabbing the parallel faces. Also, it's coplanar across each of those faces and concentric as well. So you see down in live rules, I get the green feedback showing that the live rule is on, and also that it is finding. It's also finding that condition. One thing, I talked about the pause, but let's go back to and mention the advanced live rules. If I pull this up and down, you're going to notice another tool down here. It's called advanced live rules. I hit Control E. It's going to turn on advanced live rules. It's going to pause the model, and then, like I said, I get a tree form down here. If I come down here and I turn off parallel, notice how parallel it updates, and parallel is no longer there. Right? I had parallel on just a second ago. So you see that I have symmetry and coplanar conditions, because this in green was my original select set. I can branch those out in tree form, and you see how many levels deep where we see the symmetry and so forth. So for example, I have symmetry across from the original select set in green here, and notice how it's highlighted on the screen, and that's the face. I have coplanar, because that face is coplanar to those as well. And then I also have these two faces, which are coplanar and at a different level. So let's say, for example, I want to move the select setting face in green, and I also want to move the back right face, and that's it. So I want to kind of pick and choose what faces I'm going to use. So that one's highlighted. I don't want to use that one. Notice how I can uncheck it. So that unchecks that particular live rule. I want to use that face, but I don't want to have that face come along for the ride. I don't want that face to come along for the ride. So you see how I can just kind of pick and choose, and I hit accept, and notice how now I've picked and chose which of those particular faces from the tree from advanced live rules I wanted to use. So it's very dynamic, and I get a lot of feedback by hovering my cursor over top of there. One thing I forgot to mention earlier, kind of jumping back, I skipped something when I was talking about the steering wheel. I apologize for that. I'm going to turn off live rules again. And I had this face down, and one thing I didn't show you was offsetting the primary axis. So if I come in here and I hold down Shift and I left click on the primary axis, maybe I want to type in 4. So notice how I've offset the steering wheel. Now the origin of that steering wheel is 4 millimeters above that selected face. So what that allows me to do, if I want this face to be 4 millimeters below the face behind it, I have my offset set up there. I just start my move. And because remember my from direction is on the origin, and I can select up here and say go from here to here, but because I had that 4 millimeter offset, notice how that face is now 4 millimeters below it. And I can even throw a dimension on there to double check that. So you see there's the 4 millimeter difference. So that's something I forgot to mention earlier when we were talking about the steering wheel. I apologize for that. Just to wrap up a couple things, our goal here was to introduce, and I wanted to give you some tips and tricks on with manipulating the steering wheel and defining the steering wheel. For those of you that haven't used synchronous, that's kind of the basis of it. And I encourage you to create, just a block, and just the first time you're using synchronous, or if you haven't done this before, pull the steering wheel out, hold down Control and Shift on everything, and just kind of see for yourself what it does. I illustrated each of those on the slide, but by adjusting the primary knobs, secondary knobs with both Control and Shift, and then holding down Control to do a copy, there's a lot of nice little shortcuts and quick tools to be able to manipulate the steering wheel there. We looked at the live rules. There we wanted to introduce those live rules and some of the color schemes, and I want to show you an example of advanced live rules. So this is just kind of building a little bit of foundation for those of you that haven't used synchronous technology or the live rules, or maybe you want to see what new live rules are there. We just wanted to introduce those to you. As always, I know that some of this we went through really quick, and I apologize for that. The replay will be on our YouTube channel at youtube.com/LIPLM. So that's always available for you. As far as all our other lunch bites, we have posted up there as well. Just to keep you guys informed what our next upcoming training offerings are, fundamentals for new users, update for existing users. If you want to learn more about the live rules and the steering wheel and get some hands-on practice, there's an opportunity for that with the ST3 update class as well. I really want to thank you for your attention. I know I ran over. I apologize once again. I hope you found this session very informative. Please email us your suggestions for future Lunchbyte topics. Also email us any questions you may have had during this session. Our next regularly scheduled session will be on sheet metal in 2 weeks, I believe. And once again, thanks for your attention, and have a great day.